This video is about the idea of a singularity, a point of explosive growth in intelligent machines and/or the intelligence of machines. In particular, this video will give a broad-stroke summary of David Chalmers' 2010 article, The Singularity: A Philosophical Analysis. The purpose is to provide a basis for engaging more deeply in the discourse examining some of the hopes and fears about the future and AI. David Chalmers is an Australian philosopher with many publications, particularly on consciousness. You may remember him from the Week on Consciousness as the philosopher who articulated the so-called hard problem of consciousness. His philosophical analysis of the idea of the singularity produced a significant number of replies from a diversity of fields, including cognitive science, philosophy, computer science, and psychology. Chalmers' paper is a thorough and systematic approach to a claim made in one of your readings from this week, I.J. Good's Speculations Concerning the First Ultra-Intelligent Machine, originally published in 1965. In this piece, Good mounts the skeleton of an argument for the so-called singularity, the possibility of a point at which artificial intelligence machines are intelligent enough to create their own intelligence machines with an intelligence greater than their own, and like an inside-out nesting doll, a sequence of ever more intelligent machines will be produced by means of their predecessor until we ultimately arrive at an ultra-intelligent machine. Chalmers takes this argument from Good and expands and elaborates upon the individual premises. Here, we will take a look at the basic form of the argument and examine the premises one by one to get a sense of what the argument actually says and what would need to be true such that this singularity might be a possibility, and what would need to be true such that it might be an eventuality. The form of the argument can be roughly modified to involve three premises. First, that there will be AI. Here, AI means specifically an intelligence produced in some way other than the usual way, that is, sexual reproduction, equivalent to that of an average human being. Chalmers calls this premise the equivalence premise, that AI is what is equivalent to human intelligence. The second premise states that if there is human equivalent AI, then there will be AI plus, wherein AI plus refers to some AI with intelligence greater than human-level intelligence. This, Chalmers calls the extension premise. The third premise states that if there is a greater than human-level intelligent machine, then there will be AI plus plus, or a super-intelligent machine. This final premise Chalmers dubs the amplification premise. There are a number of important assumptions that undergird each of the premises, but for the argument as a whole, it's worth acknowledging two big assumptions right off the bat. The first assumption is that intelligence is a thing. That is, that it's possible to in some way clearly articulate and account for what intelligence is. We know from week 6 that this is a so far unsolved issue, but that there are various ways around it that may require accepting certain, sometimes major, caveats. The second assumption is that, on the previous assumption that intelligence is a thing, that it is in fact a measurable and comparable thing. We can see that this may depend, to an extent, on what it turns out to be, or what we agree is, an acceptable characterization of intelligence. There are two other assumptions that play a role in the argument. First, that human-level intelligence is not already near the limit of what is physically possible. This is just to say that if human-level intelligence is constrained by physical laws in some way, then our current capacities are not anywhere near the limits of those constraints. Chalmers takes this to be plausible, but there are many facets to this debate. The second assumption is really just more of a logical distinction. An explosion in the speed in computing is logically separate from an explosion in intelligence level. As Chalmers notes, there could be, in principle, a speed explosion without an intelligence explosion, and perhaps vice versa. However, these two things are often conflated, especially under the assumption that to get AI and AI plus will require an explosion in computational speed. Note that this is not a logical necessity, but is often presumed as a sort of pragmatic one. Chalmers points out, however, that it is also logically possible that considerable cleverness in programming might alone elicit greater intelligence performance absent major gains in computing speed. Now, let's take a look at each of the premises in turn and some of the problems that come about according to how each premise is defended. Premise 1 states that we will, at some point in the future, create an AI. Now, you may notice that the slide says, there will be AI, and not specifically that we will create it. This leaves open the possibility that AI could, I guess, come about some other way. But I'll leave it up to you whether this construal of the premise is worth pursuing. Chalmers identifies two major supports for this premise. The first is the brain emulation hypothesis. This is the idea that if we understand the brain well enough, we will eventually be able to emulate it in one way or another. We are familiar with the functionalist version of this thesis, which says that so long as the causal connections between parts are realized, independent of medium, the relevant features of the brain have been emulated and intelligence should arise. But there are other ways to construe this. Brain emulation, as simply building a biochemically equivalent brain, or an electrically equivalent brain as well. These theses could perhaps hinge on the idea that both functional and more specific physical properties are relevant to emulating a brain. In any case, one way to support this first premise is to argue that there will be human equivalent AI by brain emulation, by assuming that 1. Intelligence is an outcome of functional organization of the brain or physical-chemical properties of the brain or some other property of the brain, and 2. That if these relevant properties are emulated, then you will have human equivalent intelligence. The second way this premise is supported is more by way of a possibility argument. That is, an argument for the possibility of human equivalent AI more generally. This is an argument that appeals to evolution. A refined version of this argument tends to go hand in hand with emulation arguments. Because evolution, a natural mechanical process, produced human intelligence, human beings in principle could themselves produce an intelligence by mechanical means. Note that this is less of a how possible argument, as with the brain emulation one, but simply an argument stating that it might be reasonable to suppose that it is possible, however that might be. There are problems with each of these arguments in support of premise 1. With respect to brain emulation, we're already familiar with many of the detractors from variations on brain emulation. Appeals to specific brain properties instantiated in human brains is anthropocentric and creates a messy ontology where corvid, cephalopod, and certain other mammalian intelligence is concerned, while appeals to functional properties of the human brain might be appealing to properties irrelevant to the instantiation of intelligence in humans and other creatures. There are also issues pertaining to the possibility of brain emulation as well. It's worth noting in particular that the brain is composed of around 86 billion neurons, each of which have anywhere from 500 to 5,000 connections at current best estimates. This is an insanely huge number of connections to account for at all, leaving aside the issue of their structure and organization. With respect to the evolution argument, there is the general issue of how exactly the argument is meant to be taken. Is this simply an argument for the mechanical hypothesis for intelligence? That, given evolution is a mechanical process in principle could yield intelligence? If so, there is still significant gray space here about whether a mechanical process yields something whose relevant properties are also mechanical constitutively. There is also the issue of pointing to a process that occurred on an incredibly long timescale to support the thesis that something similar could be produced artificially. What if the timescale is somehow necessary for the particulars of the mechanical process of evolution? There are certainly other ways to support this first premise, that there will be human equivalent AI sometime in the future. We know, however, that this will depend both on a notion of intelligence, a way to measure and compare it, and the possibility that whatever it is, it's possible to instantiate it in artificial systems. The second premise is sort of the hinge point of this argument. It requires that whatever got us AI, that procedure, method, or process is extendable. Supporting this premise requires either giving reason for the idea that the process of AI is able to be used for AI plus, or giving some other support for the eventuality of AI plus given AI. Note that there may be ways of getting intelligence that are not extendable to AI plus. The traditional way, sexual reproduction, is one example. Getting human-level intelligence is not extendable this way. It will only ever produce human-level intelligence. By definition, of course. At least unless or until someone has a non-human baby. However, another good example is the brain emulation idea. Even if emulating the brain is in some respect possible, and that the relevant properties for intelligence are emulatable, then this will give us human-level AI, but it is certainly no guarantee of greater than human intelligence. The means by which a brain might be emulated might not immediately lend itself to either understanding of or the possibility for instantiating higher than human intelligence. Now, it is possible that, if brain emulation turns out to be the right path, it might allow us to understand certain features of intelligence that are extendable, features for which improvements can be made that lead to AI+. It's also possible that some other path may or may not lead to an extendable method that gives rise to AI+. Note that of the premises, this one especially is steeped in considerable speculation. Premise 3 can be loosely stated as the claim that AI plus will produce AI plus plus. Whatever extendable method produced AI plus can use it to produce AI plus plus. This is the essential claim made by I.J. Good. An AI plus will have all the intelligent capacities of a human and more, including the capacity to create great intelligences. Thus, the AI plus will create AI plus plus. Ultra intelligence will be born. This idea relies on the crucial assumption that Chalmers calls the proportionality thesis. The idea that increases in intelligence lead to proportionate increases in a capacity to design intelligent systems. Note, too, that this capacity itself seems to necessarily involve different aspects, perhaps even including capacities like being able to manipulate materials, capacities which might not be regarded as specifically within the domain of intelligence. In any case, Chalmers remarks that we may need to restrict our class of machines about which we make claims like premise 3, wherein AI plus leads to AI plus plus. Specifically, we may need to restrict the class of objects under AI or AI plus to those with the specific capacity of self-improvement and system design. Supposing we can make a self-improving AI, then AI plus will occur, and AI plus, insofar as it is itself self-improving, will create AI plus plus. As mentioned near the beginning of the video, in addition to the open questions about whether and how the individual premises can be supported, there is the more general issue of the preliminary assumptions of the argument altogether, most notably the assumption that intelligence is a thing and is measurable. There are a lot of adjoining and adjacent questions that come along with these assumptions. What if intelligence is not one thing? What if intelligence as we come to know it only applies to humans? What if what is important about intelligence is its correlation with certain capacities? And what if those capacities turn out only to be correlated with intelligence within the human sphere? These questions are important not just for entertaining the possibility of the singularity, but also for understanding the philosophical and even existential motivations for considering the possibility. Why do we care about the singularity? Well, a combination of hopes and fears. On the positive side, we might hope that AI plus and or AI plus plus would bring about the end of poverty and disease, the discovery of important knowledge, and so on. In this case, we might care about the singularity because we care about the positive consequences of an explosion in the capacities for doing medicine really well, or science, or mathematics. It bears asking then, not just whether AI plus or AI plus plus is possible, but also what it would actually mean. What if quality medical research isn't correlated with intelligence, however it might end up being construed, as realized in artificial systems? And on the other hand, what if ultra intelligence turns out to be correlated with an insatiable need for domination and maximal suffering? Chalmers takes on some of these concerns in the remainder of his paper. It's useful for us, however, to think about some of the motivations for entertaining the idea in the first place. Even if the chances are very small, the benefit and risk could potentially be very large. What do you think about these issues? Should we be worried about the singularity? Hopeful? Do you think the whole thing is overblown? I look forward to hearing your thoughts in the Q&A session for week 8.